Hello everybody, welcome back to my channel. This is the Blockchain Mathematician, where we discuss all the way from blockchain, how it works and how it's used in the real world, to mathematics, physics, science, coding, and much, much more. Let's begin. In the previous few videos, we discussed the blockchain side of my channel, but now we'll be pivoting towards the power rule, which is the mathematics side of my channel. Let's begin. So the power rule is mainly used inside of derivatives, and could also be used in integrals, and which we will discuss in the future. But for today, we'll only be looking at derivatives, how we can use it with negative powers, and how we can use it with positive powers. And yeah, let's begin. So, let me just begin with the actual formula for it, or the equation. So, imagine we have to find the derivative, which this is the notation for a derivative, which here, in this section, you'll put the equation which you have, which in our case will begin with the equation x squared. So let's say we have a function x squared. So I'll plot this down on a graph. Sorry for my poor writing, but it will look something like this. A little more steep, but that's okay. I'll rewrite that. So it looks something more like this, x squared. And your goal is to find a slope on a specific point on this graph on the function of x squared. I know this may not look like x squared, like the function, but this is the best drawing I can give. And yeah, let's begin. So how can we find the derivative of x squared? Well, first we need to introduce what the power rule is. So let's we have the following equation. The derivative of x to the power of some kind of exponent, which I'll label as a. And this will be equal to a multiplied by x to the power of a minus 1. Alright, let's talk about this a little. So what we did is we took this a and we brought it to the front of the equation. So now we have a multiplied by x. But the exponent changes to the exponent which we had before, subtracted by 1. Perfect. Let's talk about this with the following example. So this will be equal to the exponent brought down to the front, which in this case is 2. So 2x to the power of a, which in our case is 2, subtracted by 1, which gives us the following equation. 2x to the power of 1, which does not do anything to our equation, as this will just equal to 2x. Yeah, perfect. So we have 2x as our final equation. So that means on any point of the specific graph which I drew of the x squared function, the derivative will be 2x. So let's substitute a point. Let's say we want to find the slope at the point of 5. So then we'll put 5 into the equation, which is equal to 2 multiplied by 5, which is equal to 10. And there you go. At the point of 5 on the x squared function, we'll get the slope of 10. Awesome. So now let's try another equation, which will be the derivative of x cubed. We'll do the same process. So we'll take the function's exponent, and we'll bring it down to the front, which will now give us 3x. And now you have to subtract the previous exponent by 1, which will give us 3 minus 1, which is equal to 2. And there you go. Once again, this is the slope of our function of x cubed. So let's imagine we're at point 2. This will be equal to 3 multiplied by 2 to the power of 2. So now we can simplify this. Remember, exponents always come first. So 2 to the power of 2 is 4. So 3 multiplied by 4, which is equal to 12. And there we go. That means at the point of 2 on the x cubed graph, we'll have a slope of 12. Awesome. And now let's do something a little bit harder. Let's imagine the function, the derivative of 1 over x, like this. You may be wondering, but where's the exponent? Well, this could be rewritten in the following expression. The derivative of x to the power of negative 1. Remember, for any expression with a negative exponent, it is equal to 1 divided by x to the divided by x to the power of the positive variation of that exponent, which is why it's equal to 1 over x to the power of 1. Awesome. So the derivative of x to the negative 1, we'll use the same process. So we'll bring down this negative 1. So now we'll have negative x to the power of a minus 1. So negative 1 minus 1 will give us negative 2. And that's how we get our final expression, and we can rewrite this in a different way. So now we have negative 1 divided by x squared. And yeah, that's it. That's exactly how you use negative exponents, positive exponents, in the power rule itself as a whole. And yeah, thank you very much for watching my video. I hope you learned something, and feel free to ask any questions in the comments below. Thank you. Have a great day.